Okay, so let's begin. Exam 1 review. Exam 1 review has many different topics to cover. The ones that I cover, that I'm going to go over on this PowerPoint are the ones that most instructors, give on the exams. Okay, maybe not every problem will be in the exam, but some of these you will see. Okay, let's begin by graphing. Graphing by plotting points. Let's say graph y equals to negative 2x plus 3. Okay, so you can construct a table with x and y. So you're going to pick values for x. So for example, if you choose negative 1 for x and 0 for x and 1 and 2, it only requires 2 points to graph. Only 2 points. But here, guys, I'm going to select 4 points, and this way you will notice that all the points are in the same line. Okay, so when x is negative 1, all we do is plug in negative 1 for the x's, and all we do is simplify. So when x is negative 1, y equals to 5. So the point will be negative 1, 5. When x equals 0, we're going to plug in 0 for the x's. This will give us y equals to 0 plus 3, y equals 3. So when x is 0, y is 3. Now let's plug in 1 for x. It will give us negative 2 plus 3. So when x is 1, y is 1. So the point will be 1, 1. And finally, when x is 2, we plug in 2 for the x's, and we evaluate or simplify, we get negative 1. So when x is 2, y is negative 1, and the point will be 2, negative 1. Now we go to our grid. Okay, so let's plot the point. Negative 1, 5 will be negative 1, and all the way 5. So we'll be about right there. And then 0, 3, this is 0, and 3 will be about right there. And then 1, 1, this is 1, and 1 will be right there. And finally, 2, negative 1, we got 2, negative 1, we go down, so it'll be right there. If you notice, all those points are in the same line. But it only takes 2 points to graph a line. And like I said earlier, I use 4 points just so you know that you can use any 2 points, but I chose 4, and this way you can pick your own points. Okay, but it's always wise to pick small integers. Okay, because the bigger the value for x, more likely it's not gonna be on your grid. It's gonna be out of range. Okay. Now I'm gonna grab the very same problem, but in another way, by using the slope-intercept form. Okay, the y equals to mx plus b. So we need to find the slope and the b. Right, my slope is negative 2, which means it's gonna go down 2 and 1 to the right. From where? From the y-intercept, which is my b. My b is 3, so this is my starting point, 0, 3. So we start at 0, 3. It'll be about right there. And then we're going to go down 2. Let's see, 1, 2, and 1 to the right. And we draw our line. You see, if you notice, it's the same line as before. So here, guys, I show you 2 different ways to graph an equation in the form y equals to mx plus b. Now let's graph another one. Here my slope is 3, which means it's going to go up 3 and 1 to the right from the y-intercept, which is my 0, negative 5. So 0, negative 5 is my starting point, which is going to be down here. Okay, then I'm going to go up 3 from the negative 5 on the y-axis, 1, 2, 3, and 1 to the right. So we connect the 2 points, and we got our line. Okay, this is not that complicated, guys, if you know exactly the rules on graphing the y equals to mx plus b form. Now, how about y equals 4? Y equals 4 is going to be a horizontal line. Right, because my slope is 0, there's no slope, or 0 slope. So we go right, so we start at 0, 4, and we graph all the points where y equals 4. You see horizontal line. observation, when the equation is y equals to a number, the horizontal line will be at that number. X equals -2. This is a slope that's undefined slope, which means it's going to be a vertical line. So we're going to go and graph x equals -2. So we're going to graph this whole line here. X equals -2. That's my line. Another observation, when the equation is x equals to a number, it's going to be a vertical line at that number. Okay, let's move on. Now we have it in the form ax plus by equals c. Some textbooks call it the standard form. Some call it the general form. But I believe in this book, the 1324, the one that we have right now, they just call it the rule. Okay, the rule of ax plus by equals c. So if it's in this form, we're going to graph it by using the, I mean, we can set it up in the equation y equals to mx plus b, but then later I'm going to show you another way. Okay, so the first thing is that we're going to add 5x to both sides. And then we're going to divide everything by -2. So my slope is -2. So it's going to go 5 down and 2 to the right. From where? From my b. My b is my y-intercept. So my starting point is 0, 5. So we're going to start here at 0, 5, up here. We're going to go down 5, 1, 2, 3, 4, 5, and 2 to the right, 1, 2. So it'll be about the point 2, 0. That's my line. Okay, now I'm going to graph it the very same equation, but in another form. Okay, this is a form ax plus by equals c. So in this form, I'm going to graph it by finding the x and y intercept. So here, here are the definition of the rules. To find the x-intercepts, we let y equals 0 and solve for x. Okay, let y equals 0. So we're going to plug in 0 for y and solve for x. We divide by -5. So x equals to 2. So my x-intercept will be 2, 0. That'll be my x-intercept. Now for the y-intercept, okay, I already plotted here at 2, 0. Now to find the y-intercept, we let x equal 0 and solve for y. So we're going to plug in 0 for the x. We get -2, y equals to -10. Divide both sides by -2. So we get y equals 5. So the point will be 0, 5. 0, 5 will be up here. And we do our line. If you notice, guys, it's the same line as before, because the equation was the same, but in the previous slide, we converted it to, or rewrote it into the form of y equals to mx plus b, which is a slope-intercept form. I believe, like I tell my students, if it's in this form, I tell my students to do it this way, by finding the x and y intercept. If it's in the y equals to mx plus b form, which is a slope-intercept form, then we use the rules on how to graph in that form. Now, but I have an easier way that I modified it for my students. Okay, check this one out. To find the x-intercept, we're going to let y equals 0. So if y is 0, can we just cover the whole -4y? Because if let me go back. Because if y is 0, it means that this whole thing will be gone. Will be 0. And then in your heads, you can divide both sides by 3. So x equals to 4. So what's my x-intercept is going to be 4, 0, my x-intercept. Now to find the y-intercept, we let x equal 0, and again we're going to cover the whole 3x, because if x is 0, they'll be gone. They'll be 0. So in your heads, you can divide both sides by -4. So the answer will be -3. And then we plot it, and we do our line. Okay. This is the way I show my students, but first I show them the concept, and then I show them this way, because this way they can get the answer real quick. Okay, now finding the slope of a line through 2 points. The slope of a line through 2 points, x1 and y1 and x2 and y2, where x1 cannot equal to x2, because if it does, then it's undefined. It's defined as the quotient of the change in y and the change in x. So this is a formula for the slope for m. Okay, let's do number 9 here. So let's let the first point be x1 and y1. So x1 is 9 and y1 is 0. And x2 is 12 and y2 is 12. There's my x1, there's my y1, my x2 and my y2. Plug into the formula. So it'll be 12 minus 0 divided by 12 minus 9. The answer will be 12 over 3, which the answer will be 4. So my slope is 4. Now, this is number 10. Right, we know that x1 is negative 5 and y1 is negative 2. x2 is negative 4 and y2 is 11. So let's plug into the formula. So it's going to be 11, which is y2, minus y1, which is negative 2. So this will give us a 13 on top. Right? And now so this changes to a positive. So it'll be 13 over 1. So the answer will just be 13. That's my slope. Let's do another one. Okay. Okay, the x1 is 5, y1 is 3, x2 is negative 7, and y2 is 3. There's my x1. There's my y1, my x2, and my y2. Let's plug them into the formula. You notice we're going to get 0 over negative 12, so the slope will be 0. Okay, now here's an observation. Okay, so like I tell my students, before you start using the slope formula, you always look at the values at the points. You look at the x's, right? And then you look at the y's. If the y's repeat, it's going to be 0 slope without doing no work. So I mean, that's why I call it an observation. If the y's repeat, like in this case, the y's repeat, is going to be 0 slope. So the slope is 0. Now look at number 12. Okay, again, by showing all the work, x1 is 1, y1 is 2, x2 is 1, and y2 is negative 6. So if we plug them into the formula, we're going to get negative 8 over 0, which is undefined. Here's the observation, another observation. When the x's repeat, right? For example, in this case, the x's repeat at both points. When the x's repeat, it's going to be undefined slope. And without doing no work, you should be able to know that. To notice that. Okay, so it's always good to observe the 2 points first, and then you look at the x values and you look at the y values. If the x values repeat, it's going to be undefined slope, and if the y values repeat, it's going to be 0 slope, and if nothing repeats, actually you're going to get a slope. Okay, either positive or negative. Okay, now find an equation of the line passing through the given points. So first the slope. First we need to find the slope, and then we're going to use a point slope formula to find the equation. There's my slope formula, and there's a point slope formula to find my equation, which is y minus y1 equals to m times parentheses x minus x1 close parentheses. So let's first find our slope. So before we start, let's check the x values. Do they repeat? No. The y values, do they repeat? No. So here, guys, we're actually going to get a positive or negative slope. Let's plug everything in. Right, x1 is negative 5, y1 is negative 2, x2 is negative 4, and y2 is going to be 11. So we plug it into the formula. It's going to be 11 minus negative 2 will give us 11 plus 2, and negative 4 minus negative 5, this will turn into a positive, so it will give us the slope of 13. So my slope is 13. Now I'm going to use point 1, my x1 and y1, I'm going to plug them in there. You see this is my x1 and my y1, which is negative 5 and negative 2, and my slope is 13. So let's plug everything in. You see here's my y1, and here's my x1. So this becomes a positive here, because 2 negatives it becomes a positive. Now here we're going to distribute. This is going to give us 13x plus 65. Then we subtract 2 to both sides. So here's my equation of the line in slope-intercept form. So this is what we were looking for. Okay, now, number 14. From these, we should be able to write the equation of the line in slope-intercept form. What do we need? We need the slope, right? And we need the b. Remember that first we'll start with the b. The b here, guys, in this case, right? And the slope will be the right over the run. So here my slope is 1. I mean, my B is 1, right? Because the B is the y-intercept. So my B is 1. Now you have to pick another point on the grid that goes exactly through a corner. I mean, for example, this is not a corner, right? Because it's like in a little bit. If you notice, this one here, it goes exactly to the corner. So this is a point that we're going to use. Okay. Now we know that this is positive slope because it's going up from left to right. So remember, the slope is a rise over the run, which means up and down the vertical over the horizontal. So in this case, we're going to go up 1, 2, 3, and to the right 1, 2, 3, 4. So my answer will be the change of y, which is 3 over 4. So I already found my b and I already found my m. So let's put them into the formula. My m is 3/4, and my b is 1. So this is the equation of the line. Y equals to 3/4 x plus 1. Let's try the next one. My b is -2. And now this one here, right, we know it's negative slope because it's going down. Okay, so we can pick, let's pick a point that goes exactly to a corner. If we notice, these on the bottom we cannot choose because they don't go exactly to a corner. Let's see this one here. This one here goes to a corner right there at -4, 3. See? Now this one here, right, is going to go down 1, 2, 3, 4, 5. It's going to go down 5. And 1, 2, 3, 4 to the right. So it's going to be -5 over 4. So my slope will be the change of y, which is -5, over the run, which is 4. So I found my b, my y-intercept, and I found my m, my slope. Plug them into the formula, into the equation, and we found our equation. Y equals to -5/4 x minus 2. Okay, now, remember on the one that we did earlier, if you have a horizontal line, it means it's going to be y equals to a number. So this number will be -3. So y equals to -3, because that's my b. Remember the observation? If you have a horizontal line, it's going to be y equals to a number. So my answer will be y equals to -3. And the last one, this is a vertical line, which is undefined. So this will be x equals to a number. So the answer will be x equals to 4. That's the equation of the line. These are very important to know, guys, or to observe, because this doesn't really require too much work. Just by knowing the concept, you'll be able to find the equation of the line on the graphs. Okay, now number 15. It says find an equation of the line with the given conditions. Pass it through the point 3, 4, and parallel to the equation 4x minus 2y equals to 5. One thing that you learn in this week is that parallel lines have the same slope, and perpendicular lines have the opposite reciprocal slope. So in this case, right, first we need to find the slope by rewriting the 4x minus 2y equals 5 in the proper form, which is in y equals to mx plus b. And then we use the point slope formula. So here, guys, we're going to subtract 4x to both sides. We divide by -2. So my slope is 2, right? So parallel lines have the same slope. So this is the slope that I'm going to be using because parallel lines have the same slope. So my slope is 2. Now I use the point slope formula. Right, my slope is 2 and my point was 3, 4. So this is my y1, my x1 is 3 and my y1 is 4. Plug everything in and solve for y. We're going to distribute. So it's going to give us 2x minus 6 on the right side. We add 4 to both sides. So we get y equals to 2x minus 2. So this is the equation that we're looking for. Y equals to 2x minus 2. Now, there's another way to find the equation without using the point slope formula. Okay? If you have y equals to mx plus b, right? If we're solving for b, we subtract mx to both sides, so we get b equals to y minus mx. This is how you find b. So I already know what the slope is, right? We got it earlier, which is 2. my x1 is 3 and my y1 is 4, so I'm going to plug him in the formula. So b equals to y is 4, my m is 2, and my x is 3. So we get b equals to -2. So the answer will be the same as before, y equals to 2x minus 2. See, guys, you get the same thing. So here I like to give my students an option of what to use, because maybe the Poinsot formula might be easier to somebody, and this one is more student friendly, because for this class you're able to use a calculator, so you can just plug in the calculator if you struggle with algebra. Okay, but this is the formula that they use in my math lab, and this is something that I tell my students that they can use as an alternative. Okay. Now they want to find an equation of the line with the given conditions. They pass it through the point 6,8 and perpendicular to the equation -2x plus y equals to -3. So again, we need to rewrite the -2x plus y equals to -3 and slope in the set form, and y equals to mx plus b. So in other words, we have to solve for y. So we add 2x to both sides. So y equals to 2x minus 3, so the slope is 2. Remember that perpendicular lines have the opposite, which means the opposite side, and the reciprocal. So in this case, it's going to give us -1/2. So these two slopes are perpendicular. Now we have my slope, I got my point. Okay, we can use the Poinsot formula. Plug everything in. There's my y, which is 8. My x1 is 6, and my slope is -1/2. Here, guys, I'm going to distribute. Then finally, I'm going to add 8 to both sides. So there's my equation. Y equals to -1/2 x plus 11. Okay. Now, number 17. They want you to evaluate. Evaluating functions. Say they give you f of x equals to x squared minus x plus 4. They want you to evaluate it. So for A part, we're going to evaluate it at -2, which means when x is -2, the resulting answer will be my y. Okay, that means that I'm going to plug in -2 for every x. So f of -2 will give us -2 squared minus -2 plus 4. The answer will give us 10. Okay, so when x is -2x, my y is 10. Now let's evaluate f of 3. Okay, the same procedure as before. We're going to plug in. Because there's supposed to be a 3, guys. For some reason, I put a 5 there. Because it's supposed to be a 5. I'm sorry, guys. This is a misprint here. It was supposed to be a 5. So we're going to plug in 5. Okay. So we'll get 20 minus 5 plus 4. We'll get 24. So when x is 5, b is 24. Okay, I'm going to fix that for the next time. There's supposed to be a 5 there. But when x is 5, y is 24. Now there's the C part. They want you to evaluate the function at x plus h, which means I'm going to plug in x plus h for every x. You see I plug it in there and there. Now x plus h squared will give you x squared plus 2xh plus h squared. So this replaces the x plus h squared. Then we just bring down the minus x plus h plus 4. Because with this minus here, right, that's going to be negative and that's going to be negative. So this becomes negative x minus h plus 4. So this is my solution for that one, guys. Okay, now let's put D. Let's find D. This is called find the difference quotient. F of x plus h minus f of x over h. If you're taking the next course at 1325, you have to know this because this is we do the differentiation of derivatives in calculus. But the 1325 course, the one after this one, if you're going for math or for business or for accounting, you have to know this formula here. So anyway, so first, let's start by finding f of x plus h. We plug in x plus h for every x. Right, and this is what we did on the previous one on part C. So we're going to get x squared plus x squared plus 2xh plus h squared. That's x plus h squared minus x plus h. So here, guys, we distribute the negative, so we get x squared plus 2xh plus h squared minus x minus h plus 4. That's my f of x, f of x plus h. Now this is step 2, guys. That was step 1. This is step 2. I kind of break it in 3 parts. So now we're going to do the f of x plus h minus f of x. The f of x plus h, we just got it right now, right? Which is x squared plus 2xh plus h squared minus x minus h plus 4. Minus my original function, which was x squared minus x plus 4. With a negative here, guys, means that all these signs will switch because you're multiplying by negative 1. So that becomes a negative x squared. That becomes a positive x. And that becomes a negative 4. Now, here's why I tell my students that every term, okay, we're going to combine like terms. But every term that doesn't have an h must cancel. Okay, that's like a hint that I tell my students. I mean, will be eliminated. For example, x squared doesn't have an h, right? So there has to be a negative x squared somewhere, you see, and there it is right there. Right, 2xh, because there's no other term, there's no other like term, like, I mean, with an xh, so that one stays. This one doesn't have an h, right? So the negative x cancels with a positive x. And the positive 4 cancels or is eliminated with a negative 4. So this is what's left. Now we have to finish it off, which is part 3. Here, guys, I'm going to factor out an h. Why do I do that for? Is to set up part 3. That way the h on the bottom here on the difference quotient formula, that will be eliminated or they will cancel. Right, so the h is canceled. So this is my solution, 2x plus h minus 1. Okay, now let's do another one, but not as complicated. Okay, again, we do the same thing. This will be much easier because the x, the variable, is to the first power, is not squared. So what we do is plug in x plus h for the x. That will give us 2x plus 2h minus 3. Now comes part 2. F of x plus h minus f of x. This is my f of x plus h. Minus f of x is the original function. We distribute the negatives, so we get negative 2x plus 3. And we just bring down the 2x plus 2h minus 3. Now remember that the terms with no h must be eliminated. So the 2x cancels with a negative 2x. And the negative 3 cancels with a positive 3. So we're left with 2h. Now comes the last step. The h is canceled because h over h is 1, and 2 times 1 is 2. That's my solution. Okay, now, this is number 19. This is how linear equations are involved in the real world. This is like a real life situation here. The manufacturer's suggested retail price, which is an MSRP for a new base model Toyota price, is $25,035. And it is expected to be worth $14,115 in 4 years. So for A part, find a linear depreciation function for this car. So here, guys, we have to find 2 points. But if we notice, when x is 0, right, this is before the car went out to the streets, right? So before, when it was brand new, right, the x is 0, so this is my y. So the first point will be 0, 25,035. Then 4 years later, right, so then my next point will come when, and 4 years later, the car is worth 14,115. So it's going to be 4 and 14,115. So I got my 2 points. So now I need to find the slope. Right, so this is my x1, y1, x2, y2. Plug them in there. So we get negative 10,920 divided by 4 will give us negative 2,730. So that's my slope. Now, I like to use the b equals to y minus mx. So my y is 25,035. My slope is negative 2,730, and my x is 0. That's my b. Anyway, like an observation, guys, when x is 0, this has to be my y-intercept, right, from before. So all this work, we could eliminate all that work if we could remember that when x is 0, I mean, whatever the b is, this is the y-intercept. That's your b. So I got my slope and my intercept, my b. We put them together, so that's the answer for part A. Okay. Now for part B, estimate the value of the car in 5 years from now. So that means for part B, we're going to evaluate f of 5, which means I'm going to plug in 5 for the x. We use a calculator, so we get 11,385. So in 5 years, the car will be worth $11,385. That's how much the car went down or lost some value. The whole part C, at what rate is a car depreciating? It means what's the slope, right? But we don't put negative because the depreciating means it's already negative. The answer will be $2,730 per year. That's the answer for part C. Okay, now number 20. Here, guys, is where we have to find the cost, the revenue, and the profit function. A company manufactures 65-inch TVs that sells to retailers for $500. The cost of making X of these TVs is, the cost function is C of X equals to 300X plus 213. I forgot to put another zero, guys. It's supposed to be 213,000. Okay. Find the revenue function, find the profit function, and what's the profit of selling 2,500 TVs. Solution, guys. So the revenue is the selling price. So the selling price is 500. So it's going to be R of X equals to 500X. A mistake that students make is that they don't put R of X. They just put 500, which is wrong, because it's you're looking for the revenue function, which has to have right. So this is the revenue function. R of X equals to 500X. Find the profit function. The profit function is R of X minus C of X. So it'll be 500X minus 300X plus 213. This is my cost function. Distribute the negative. So it'll be negative 300X minus 213,000. Combine the like terms. So 500X minus 300X will give us 200X. So this is my profit function. 200X minus 213. Now, part C, what's the profit of selling 2,500 TVs? So I'm going to evaluate the profit function at 2,500. We plug in 2,500 for the X, and we use a calculator. So the answer will be 287,000. So that's how much profit you would get after selling 2,500 TVs. Okay, now, let's see what else. Okay, now comes, this is finding find the vertex, the axis of symmetry, y-intercept, and x-intercept of the function. Okay, so I'm going to tell you how to find everything, guys. So this is the form of the function, ax squared plus bx plus c. The vertex will be negative b over 2a, and f of negative b over 2a. This means this is how to find the x part of the vertex, and for the y part means whatever you got for x, you plug it into the original. The axis of symmetry, once you find your vertex, you also find your axis of symmetry. The axis of symmetry will be the x part of the vertex, which is negative b over 2a. The y-intercept is visual. Just by observing the function, you should be able to get the y-intercept without doing no work. The y-intercept will be 0c. And for the x-intercept, you have to know how to factor. Okay? So here we go. My a is going to be 1, and my b is 10. So negative b over 2a is going to give you negative 10 over 2 times 1, which will give us negative 5. Now we find f of negative 5. We plug in negative 5 to the original, which is right. I'm going to plug it in there where the x is, and also where the x is with a 10. We evaluate it, so we get negative 16. So my vertex will be -5, -16 is my vertex. Once you find your vertex, you already found the axial symmetry because it's going to be the x part of the vertex, which will be x equals to -5. That's the axial symmetry. The y-intercept is your c. In this case, my c is a 9, right? So it's going to be 0, 9. That's your y-intercept. Now for the x-intercept, we're going to have to know how to factor. So here, guys, it tells me that the signs are going to be the same, and they're both going to be positive. It's going to give us x plus 9 and x plus 1. So x plus 9 equals 0, and x plus 1 equals 0. So here we get x equals to -9, and x equals to -1. And in most cases, they also want you to graph it, okay, but not in this case. But most instructors will say to graph it. By graphing it, all you do is plot all the points and do your parabola. Okay, now, this is also finding the same thing as before. Find the vertex, axial symmetry, y-intercept, and x-intercept of the function. But now, this is in the vertex form. Okay, the vertex is going to be hk. Because here, guys, what's visual is a vertex and the axial symmetry. Without doing no work, you should be able to find the vertex and the axial symmetry. Right? If you notice, and again, the axial symmetry will be the h part because that'll be the x part of the vertex. For the y-intercept, we're going to let x equal 0 and solve for y. And for the x-intercept, we're going to let y equal 0 and solve for x. So my vertex will be -3, 16. That's my vertex. Now the axial symmetry is the x part of the vertex, which will be x equals to -3. Okay, now let's find the y-intercept. So it says to let x equal 0. So we're going to let x equal 0. They will give us 3 squared minus 16. They will give us 9 minus 16, which will give us -7. So the y-intercept will be 0, -7. Now for the x-intercept, we're going to let y equal 0 and solve for x. So g of x is the same thing as y. So we let that equal to 0. We're going to add 16 to both sides. Now we're going to take the square root of both sides to eliminate the square. Okay, I brought this to the left and the 16 to the right. Right, so the square root and the square, they cancel each other. So we got x plus 3 equals to plus or minus 4. Because the square root of 16 is 4. Now we subtract 3 from both sides. So we get -3 plus or minus 4. So we have -3 plus 4 and -3 minus 4. So here the answer will be 1 and -7. So those are my x-intercepts. And again, most of the times I want you to graph it. You can graph it by plotting all the points, and it's going to be a parabola. Okay, now let's use it. Let's use quadratic functions in real life. Okay, this is an example. Number 23. The revenue for McDonald's Corporation in billions of dollars for the years 2010 to 2015 can be approximated by the quadratic function r of x equals to -1/2 x squared plus 13x minus 57, where x equals 10 corresponds to the year 2010. They want you to find the vertex for A part. For B part, it's supposed to be in what year? In what year during this period was the revenue at the maximum? And for part C, what was the maximum revenue to the nearest $1 billion? So let's find the vertex first for part A. So my A is -1/2 or -0.5, and my B is 13. So plug into the formula. So we get -13 over 2 times -0.5 will give us -1. And 13 divided by -1 will give us 13. Now to find the y value of the vertex, we plug in 13 for every x on the original function. So we get 27.5. So my vertex will be 13, 27.5. Okay, now for part B, hey guys, once you find your vertex, you already find the solutions for part B and C. For part B, the answer will be the x part of the vertex. And for part C will be the y part of the vertex, the maximum revenue. But they don't want 13. They're saying in what year? right? So if x equals 10 corresponds to the year 2010, then x equals 13 corresponds to the year 2013. So the answer will be in 2013, the revenue was at a maximum. Now, what was the maximum revenue? Will be the y part of the vertex. I want you to round off to the nearest $1 billion. Right, so 27.5, you round it off, will give us 28 billion. So that will be my maximum revenue, 28 billion. And I believe, guys, this is all for this exam review. And I do, when I give my exams, I do give students some of these problems that are in here. Every problem that I give in the exam is in here, but I don't assign every single one, because if the class is 50 minutes, they don't have time to do all these problems. So it depends on the class, but all these are part of my exams. And I believe other instructors use something similar than what I use here. Okay, guys, let me go back. If you have any questions, please let me know.
Thank you, Mr. Isasi, for this amazing presentation. For the next week, we have for Math 13-14 exponential and logarithmic functions. And for Math 13-24, we have the exam to review. Thank you for all the audience, and see you the next week. Bye all.